We're going to have a quiz tomorrow, and this is number 4, bottom left of your worksheet. I think it's the only one that I have not explained on video. Everything has been explained on video, right? This is the final video, final question. Do you need to watch all the videos? No, right? Like I said, it's kind of like having a refrigerator full of food. If you're hungry, go for it. Open it up and eat, you know? But if you're full, I mean, you don't have to open it up. So you have all these videos explaining every single question. Now, because this is the last one, I decided to write out all the possible details of this parabola. All the things I could ask for on tomorrow's quiz. I'm definitely, for sure, going to ask for the vertex. And you need this formula to find it. I already even have it set up to plug in our numbers. You're also going to need to find the axis of symmetry, which is simply the x value of your vertex. You're going to have to state the domain, the x values, which is always going to be x equals all real numbers when it comes to parabolas that open down or open up. We're also going to ask you for the Y-Intercept. How do you find the Y-Intercept? You set x equal to 0 and solve. And you could also make the note that your Y-Intercept value of a standard form equation will always be the c value. Because when you set x equal to 0, everything cancels out except the c value. So for the Y-intercept value, you could also write down the note right here that it's always going to be your c value, but it has to be in standard form. And finally, state the min or max value. That's depending if it opens up or down. And I could even ask you that right now. Is this going to be a minimum value or a maximum value? Does this open up or down? It opens up because the a value is positive. So if it's opening up, do you have a minimum value or a maximum value? Check it out. It's up here, it's going down, reaches the minimum point, and then it comes back up. Does it have a minimum value or maximum value?
Minimum value.
Minimum value, that's right. Okay, so we'll get to that later. Let's start with number 1, finding the vertex. Now this one's probably the most challenging one because we do end up with fractions or decimals. It depends if you're using a calculator or not. So let's find the vertex by doing negative b over 2a. The b value is what? 1. Okay, so we're going to put a 1 right there into the b spot. And the a value is what? What's the a value, guys? 1/2. All right. So what I want to do is I want to zoom in here, and I want to plug in my 1/2 right in here. And let's work this out. Well, on top, I really do have a negative 1. And on the bottom, the 2 and the 2 cancel out, and there's really just the 1 left. And my final answer is negative 1. You guys agree? Okay, so let's go back to the vertex and put a negative 1 for x. And let's find the y value. Once you have the x value of your vertex, what do you do to find the y value? You simply plug it in, correct? So I've rewritten the equation right there, 1/2 x squared plus x minus 3, but instead of the x's I put parentheses, and I'm actually going to plug in the negative 1 right in there and the negative 1 right in there. So when I do this simplification, I do exponents first. Negative 1 squared really is 1, and 1/2 times 1 is going to be 1/2. Okay, and then let me bring down the plus negative 1 and the minus 3. Okay. So we could think about money here. Let's say I have $0.50, 50 cents, plus negative 1. Let's say I owe $1 and I have 50 cents. How do I end up? Right here, the 1/2 plus negative 1. That's like I have 50 cents, but I owe somebody $1. I'm still going to owe him 50, right? So that's really negative 1/2. What I just circled, that's really negative 1/2. Now, what if I did the negative 1/2 with the negative 3? What does that end up being? Negative 3 and 1/2, right? So your y value is really negative 3 and 1/2. And you could put it as negative 3 and 1/2, or you could put it as negative 3.5, whatever you want. See, both the same thing. So let's graph that vertex. We're going to go to negative 1 on the x and negative 3.5 on the y, or negative 3.5 on the y. So when I go negative 1 on the x and negative 3.5, I'm in between the negative 3 and the negative 4. I'm going to put a dot right there. You guys agree with me? Understand? Okay, what do I do after drawing my vertex? Well, number 2 right here says axis of symmetry. Now, what if I wanted to write the axis of symmetry equation? What would that be? What's my axis of symmetry equation? X equals what? X equals -1. Okay, so this is very important that you put that X equals and the X value of your vertex. You have to write X equals -1. If on the answer spot you just write -1, you're just giving me a number. You're not giving me a vertical line. In order for you to talk about a vertical line, it has to be the equation X equals -1. That'll give you a vertical line running up and down right through the x-axis value of -1. So I've stated the equation, but I still need to draw it. Drawing it's a lot easier than stating the, I mean, both are easy actually. But let me draw it by just drawing a vertical line. I like to do it dotted right through the vertex. So now we could graph this parabola if we had more coordinates. If we had more coordinates, okay? So which is the easiest, or how do I find more coordinates? XY table, thank you. So let's actually draw an XY table right here on the side. And the XY table is really an input-output table. You could plug in as many points as you want, but we only need like 2. Technically we only need 1, but you know, 2's better. And especially sometimes points are off the graph, then you wouldn't even use them. So which is the easiest value to plug in? 0. And ladies and gentlemen, when you plug in 0 for x, when you set x equal to 0, technically what you're doing is finding the y-intercept, right? So when you set x equal to 0, you're finding the y-intercept. And the y-intercept is just your c value. Okay, it's just your c value. So when I plug in 0, and that's totally logical when we say it's just your c value, because when I plug in 0 for x, you're plugging in a 0 right there, a 0 right there. Everything cancels out except the c value. So when you plug in 0, you get out a -3. That's technically your y-intercept value right there. Okay? And let's graph it. 0, -3. Let's see. Here's 0 on the x right there. -1, 2, 3. There it is. Let me put a dot right there at 0, -3. I might as well map it over to the other side of the axis of symmetry, the reflection line. That's going to be right there. So what do you guys think? This is my parabola so far. Is that good enough? No. No, right? So, I mean, if you leave it like that, I give you partial credit. But this is where you're like, okay, I need to at least plug in one more point, right? If your parabola is super tiny, plug in more values. So you've already plugged in 0, which is clearly on the right side of the axis of symmetry. It would be pointless to plug in -2 because I already know that my answer is going to be -3 because I mapped it over. It would be pointless to plug in -1 because we already plugged in -1 for the vertex. So what value would be good to plug in? 1. You could plug in 1. Now, if I do decide to plug in 1, and then I come up here and I look at my equation, and I think, okay, oh, 1 squared. Yeesh, okay, let me go with it. 1 squared, that's 1, yeah? And 1 times half. What's 1 times half? 1/2. And what's 1/2 plus 1? 1 and 1/2. And what's 1 and 1/2? 1.5 minus 3. That's like saying $1.50 minus 3. That's -1.5. Now, let's say you didn't want to deal with fractions, then you probably want to pick a different number other than 1 that'll make this fraction 1/2 cancel out, right? But let's go with this decimal. So we have 1 on the x, -1.5 on the y, 1 on the x, negative, okay, so let me show you here. 1 on the x, -1, and then half, right? Let's put a dot right there. And you could map it over. Now what do I mean by map it over? This dot right here that's in the middle, when I count how many units it is to the axis of symmetry, it's 1, 2 units. So I need to go 1, 2 units this way, and it has to be perfectly at the same y level, which is in the middle. Right there. You guys with me? So this is already a better looking parabola. Okay? Let's still go for another one, just for fun. Which other value would be good to plug in? A 2 would be great. You know why? Because 2 squared is 4, and 4 is divisible by 2. So maybe if you wanted to, you could have skipped the input of 1. You could have skipped the input of 1 and just jumped to 2, because 2 ends up giving you a nicer answer. Let me try to do this in my head. If not, we'll just jot down some notes here. But let's go with 2 squared. What's that? What's 4 times half? Okay, let me at least write down that this whole thing right here is 2 up here. Okay. And then what is x? We're plugging in 2. So we have 2 plus 2, and then minus 3 at the very end. What's 2 plus 2 minus 3? 1. Okay, so when I plug in 2, I get out a 1. And that's another coordinate. So let's go to the coordinate 2, 1. 2 on the x, 1 on the y. There we are. Map it over to the other side. How many units is it? It's 1 unit, 2 units, 3 units. So let's go 3 units to the left. 1, 2, 3, and put a dot right there. And I think this is a great parabola. You could just put some arrows on it. Any questions? Yes, I used 3 coordinates. Could I have used more? Yeah, you could use as many as you want. You could keep plugging in, keep pulling out. But this is perfect for tomorrow's test. So I hope we all understand how to do that. And I do want to review the pattern. When you have your A value equal to 1, you could use a pattern 1, 1, 2, 4, 3, 9. Now, again, these are not coordinates. This is the pattern from the vertex. So if this equation had the A value of 1, it doesn't. It has an A value of half. But if it had the A value of 1, then from the vertex, you could go 1 over 1 up. You could go 2 over 4 up, 3 over 9 up, right? But it's not. It's the A value is 1/2, not 1. Now, let me just show you or relate to you how you could actually modify this pattern to be able to graph. Okay, so if you have an A value of 1/2, you could technically multiply on your pattern the second number multiplied by the A value 1/2. And that'll give you your new pattern that you could use. And we're multiplying everything by 1/2 because this A value is not 1, it's 1/2. So my new pattern will be 1 from the vertex to the left or right, and then 1 times half is 1/2. Okay? And then over here 2, and then 4 times 2 is 2. And then 3, and 9 times half is 4.5. Okay, so let me just prove to you that this pattern still works. The pattern of 1, 1/2 instead of 1, 1. 2, 2 instead of 2, 4. 3, 4.5 instead of 3, 9. So if we went to our vertex and we went 1 over and then halfway up, we'd get to that dot that we had on our graph. If we went 2 over and 2 up from the vertex, 2 over and then 1, 2 up, we'd be at that point on the parabola. 3 over and 4.5 up. Think about that. 1, 2, 3 over, and then 1, halfway 2, halfway 3, 4, and then 4.5 would get you to that point right there. Does that make sense? So it's up to you guys. I honestly, when the A value is not 1, if it's 1/2, I like using a table and just sticking with the original way of graphing any function, plugging in some numbers, pulling out some answers. That's what I like to do. But if you love the pattern 1, 1, 2, 4, 3, 9, you could modify the pattern 1, 1, 2, 4, 3, 9 by multiplying all your second numbers by your A value. So you could have a new pattern, this one and this one, this one and this one, this one and this one, right? I hope this helps.